Hello again, sports fans. Mr. Noldy here. Today we're going to be looking at the quotient rule for taking derivatives. So if you have a quotient like this is a formula that you can use to take the derivative. So function on the top divided by a function on the bottom. Here I have f and g. So it is the derivative of the first times the second minus, not a plus like the product rule, minus the coefficient of, the derivative of the second times the first, and then it's all divided by the square of whatever is in the denominator. So we'll look at this one. So the first thing we would do is, let's see, y prime, because we have a y here. So this is going to be equal to the derivative of the top. So the derivative of 5x minus 2 is just 5 times the bottom. Well, the bottom is x squared plus 1 minus the derivative of the bottom. Well, the derivative of x squared plus 1 is just 2x, and that gets multiplied times the top, which is 5x minus 2. So what we would be doing next is just draw a big fraction bar, and whatever's on the bottom, all right, the g of x, that gets squared. So that whole quantity is squared. So right now you've technically taken the derivative of this, but usually we'll clean up the top a little bit just to make things a little bit easier later on in the course. So y prime, let me start by distributing this 5. 5 times x squared is 5x squared. 5 times 1 is 5. Negative 2x times 5x is negative 10x squared. And negative 2x times negative 2, that's a positive 4x. And that's all over, make a better fraction bar there, that's all over this x squared plus 1 quantity squared. So the last thing we would do up top here is combine our like terms. So I have an x squared here and an x squared here. So 5 and negative 10 gives me, let's see, negative 5 x squared. And then I have a 4x and a plus 5. And that would be all over this x squared plus 1, the quantity squared. And that, friends, is our first derivative using the quotient rule. All right, here's another one that's a little bit of a trick question. Could we use this quotient rule to take the derivative of this? Yeah, we could. But this one, because you're just dividing by a number, might be a little bit easier to say, hey, I'm going to write this as 1/3 x squared plus 6 divided by 3 is 2. And 15 divided by 3, well, that is 5. So by doing this, you see, now we can go through term by term and just take the derivative that way. So nice and easy. 2 times 1/3, that's 2/3 x plus 2. And of course the constant will go to 0. So we would just have 2/3 x plus 2 for this one. So we didn't, even though it was written as a quotient, you don't always have to use the quotient rule if you don't have to. All right, so here's a third example for just for good measure. Here we definitely will have to use this quotient rule because I have a function in the top and a function in the bottom. So to take the derivative, we start by writing g prime of x. And that's going to be equal to the derivative of the top times the bottom. Well, the derivative of sine is cosine. So derivative of sine x is cosine x. And then that gets multiplied by bottom, x squared. Then we take the bottom subtract. The derivative of x squared is 2x, and then we multiply by the top, which is the sine of x. And that's all over the bottom squared. So that would be x squared squared. So I'll write that out for right now. Make these parentheses show up a little better. So simplify a little bit on top. You end up with, let's see here, x squared cosine x minus 2x times the sine of x, and that is all over, I think my marker's running out, and that's all over the bottom squared. So I'm going to rewrite that right now as x to the 4th. X squared, if you did simplify on the top, you could factor out an x, and that would leave you with cosine, that would leave you with x cosine x minus 2 sine x. And in the bottom, x to the 4th. And one of those could cancel. Again, we're assuming that x is not equal to 0 here. So let me go this way with it. If one of those x's cancels, then I just have x cosine x minus 2 sine x. And that's going to be all over x cubed. So that would be a more simplified form of it. When you do set it equal to 0, just like this one, this might be a little bit easier to work with as well. So ladies and gentlemen, that's it for today. 3 examples that use the quotient rule to take a derivative. Don't forget to like the video, subscribe, leave comments, the whole 9 yards. The algorithm likes that. So until the next time, Mr. Noldy signing out.